Hey guys, welcome back to another video. I'm Nightbite, and today I'll be covering a question on the rates of change. This question is from the O-Levels 2021, Paper 1, Question 13. A spherical balloon is being inflated with helium gas at a constant rate of 500 cm3 per second. The balloon is initially empty. The first part of the question asks us to find the radius of the balloon after 1 minute. First, we need to recall our formula of the volume of a sphere, V equals 4 over 3 pi r cubed. We then need to make the radius of the balloon the subject of the equation. After some calculation, we should get r equals cube root 3v over 4 pi. Next, we find the volume of the balloon. Since the rate of change of volume of the balloon is already given, we can multiply that with 60 seconds to get 30,000 cm3. We simply then just substitute v equals 30,000 into the equation of r we had made earlier. To three significant figures, the radius of the balloon after 1 minute is 19.3 cm. Next, we have to find the rate at which the radius of the balloon is increasing at after 1 minute, a classic rates of change question. First, we should write out all our available information, and so we write down that the rate of change of volume with respect to time is 500 cm3 per second. We then have to differentiate the volume of the balloon with respect to the radius of the balloon, which should be 4 pi r squared. Using the chain rule, we know that dv over dt is equal to dv over dr multiplied by dr over dt. To get the rate of change of the radius of the balloon with respect to time, we can move dv over dr to the other side to get dr over dt equals dv over dt divided by dv over dr. And after substituting their respective values, dr over dt equals 250 over 2 pi r squared. Since we know that the radius of the balloon is 19.275 cm to 5 significant figures after 1 minute, we substitute r equals 19.275 into dr over dt. After calculating, the rate at which the balloon is increasing after 1 minute is 0.107 cm per second to 3 significant figures. Don't forget to include the unit cm per second since we are calculating the rate. Now, for the next part, when the weather balloon is subject to different pressures, the pressure P atmospheres and the volume V liters of the air in the balloon are related by the formula PV equals K, where K is a constant. Given that when P equals 1.2, V equals 2, find the rate at which V is changing with respect to P when V equals 2. This part is extremely wordy, but to simplify it, we know PV equals K, and when P equals 1.2, V equals 2. First, we should find the constant K. This is easier said by done by substituting the values of P and V given by the question, P equals 1.2 and V equals 2. And after calculating K is equals to 2.4. Since we want to find the rate of change of V with respect to P, we will need to make V the subject. Moving P to the right, V equals 2.4 over P. We then differentiate V with respect to P to get dV over dP equals negative 2.4 over P squared. Now, since we are finding the rate of change of V with respect to P when V equals 2, we know that P equals 1.2 when V equals 2. Thus, we can substitute P equals 1.2 into dV over dP, getting a value of negative 5 over 3 or negative 1.67 liters per atmosphere to 3 significant figures. With that, the question is done. Thank you for watching and see you soon. All the best for your AMF papers.